Project Scope. Consider a chemical reaction. Consider a hypothetical reactor. Here we have a theoretical fluidized bed reactor built in Inventor. This reactor is designed to crack alkanes to form alkenes. In order to do this, a catalyst must be used, known as H-beta zeolite. Here we have a transparent perspective of the fluidized bed reactor. This perspective shows the H-beta zeolite packed within the reactor's volume. Here's a closer look at a layer of the cylindrical catalyst packing within the reactor. We start our process with raw algae, then the alkanes are separated in an earlier stage before entering the reactor. The alkanes enter the reactor where they meet with the zeolite and are gradually processed into smaller alkenes. Here's a full animation of the reactor process. The solvent containing the alkanes enters the reactor through the top. The reactor starts cracking the alkanes as the liquid is processed through. The product alkenes then exit the reactor where they can be obtained and used in a later process. Here's the transparent version of the same design, again, showing the layers of zeolite catalyst contained within the reactor's volume. This is the program we've designed in order to solve the change in enthalpy within the reactor. The program first requests the number of carbons for the reactant alkane, 25 carbons in this case. The program then asks the user if the products will be alkane and alkene or alkene and alkene. 0 and 1 are used to represent the possible products. In this case, alkane and alkene was chosen. The program then asks the user for the number of carbons within the alkane product. In this case, 10 carbons. The program then asks the user for the number of carbons within the alkene product, in this case, 15 carbons. The change in the enthalpy for the system is immediately calculated and displayed. The program then asks the user if they'd like to calculate another enthalpy change. In this case, 0 was entered, and the program was ended. Safety considerations. The hydrocarbons within our process are highly flammable. Because our process involves high temperatures and pressures, this is a serious safety concern. Proper labeling, hazard signs, extinguishers, and other precautions should be used. Asphyxiants produced. An asphyxiant is a substance that can cause unconsciousness or death by suffocation. Cyanotoxins are a toxin produced specifically from certain types of algae. If these algae are to be used within the process, then proper precautions should be taken